Well,
Thank you.
Thank you, Dr. Sekman. And if there's no further question, we can move to the next paper. Just Professor Alkan explain the paper 60 will be recorded and uploaded, as understood. And then, okay, it's still the case, isn't it? Then we can move to the
thank you. The other author, industrial colleague, is away, but okay. It is better to present together. It will be more efficient.
No,
so we skip it.
Definitely.
Sorry
it's
about
quite
that.
interesting. Yes, I'm sure we will. Yeah, but it will be in the system sometimes. Okay, and we can move to the next paper. It's the paper by Dr. Köseoğlu and Dr. Akman and then Dr. Çınar. The title is Environmental Cost Benefits of Cold Ironing System in Green Container Ports for 2020-2030, and it's a case study in Turkey. And yes, the dear presenter, stage is yours. Dr. Köseoğlu. Thank you.
Hello, everyone. Can you hear me?
Yes.
Okay. Just a correction. Myself and Mr. Çınar does not have a PhD yet, but Mr. Akman has. So we are just have our master's degrees. I'm going to share a screen now, just a little bit delay. Okay. I think it's on, right? You can see it.
Yes, please.
Okay.
Yes.
My name is Mesut Can Köseoğlu. I'm a research assistant at Piraeus University Maritime Faculty. I completed my bachelor degree in maritime transportation and management engineering in Piraeus University, then completed my master's degree in Istanbul Technical University, maritime transportation engineering. Now I'm working on my second master's degree in industrial engineering in Galatasaray University. My study fields are green ports, smart shipping technologies, and ship routing optimization. Now I'm going to continue my presentation. Our study is called Environmental Cost and Benefit Analysis of Cold Ironing Systems in Green Container Ports for 2020-2030, a case study in Turkey. The contents of the presentation will be aim of the study. What are the green ports? Green ports in Turkey, cold ironing systems, methodology and materials we have used in this study, the case study, and the results and conclusion. The aim of this study was to find the answers to whether it is environmentally beneficial to invest in cold ironing systems for port management companies. The main focus has been researching the viability and feasibility of cold ironing systems in green ports with the environmental and financial perspective. The green ports are environmentally friendly and sustainable ports that meets the environmental requirements. In green ports, when policies are considered, practices should include factors such as environmental and natural life friendly approaches, keeping the pollution level at the lowest possible level, using renewable energy applications and recycling. And there is a connection between the environmental problems that ports face in order to become sustainable and criteria specified in the international literature and legislations. 10 most international green port criteria has been established as the air quality, waste management, energy consumption, noise, ship weights, relationship with residents, dredging, dust, port development, and water quality, as seen in the figure on the right. These criteria pave the way for low energy and water use, waste management, and air quality, as well as lowering cost and development of social relations, and the prestige of being a green receiving investment from funds. Green ports in Turkey rely on green port policies that ensure the inclusion of sustainable practices in development and operations of ports with an organizational culture aimed at increasing environmental awareness. With spreading green culture, it extends to ports customers as well as the port employees. In Turkey, as seen in the figure, it is not a requirement to be included in the green port projects. On a voluntary basis by many leading ports in Turkey, green port projects are adopted with the idea that it is an element of prestige, a way of keeping up with the global developments, which also enables the spreading of greener approaches and environmental measures, as well as increase in such applications. Now, in the cold ironing systems defined as the practice of cooling down of the iron coal fired engines while ships were moored at berths in the past. Ships may utilize CI or cold ironing either from the ship to ship, such as military applications, or from shore to ship, while only shore to ship connections have environmental benefits. CI involves moored ships to shut down their generators and the use of clean energy provided by the shore supply unit to power main systems and to meet the power demand of all onboard operational facilities such as cargo equipment and accommodation parts. This technology enables moored ships to use shore power rather than them utilizing their onboard auxiliary engine generated power to reduce emissions at ports. Cold ironing is an initiative that will help the shipping industry contribute to this goal, and it will dramatically eliminate the noise from generators while at port. It will also reduce the different types of local emissions, and it will potentially reduce the operational cost because of the large-scale electricity generation is typically cheaper than running diesel generators. Operational diesel generators for ships to cover their electricity requirement has a large effect on air pollution. These generators or auxiliary engines of ships burn cheap, less pure, poor quality and low efficiency diesel fuel, resulting them to emit high amounts of air pollutants. Cold ironing systems consist of three main components, which are a shore-to-side electrical system, an infrastructure, a cable management system, and a ship-side electrical system. The shore-side electrical systems transmits power from high-voltage substations to connecting points near ships, which are distributed boxes at terminals to transform voltage levels, convert frequencies, switch between ships' power receiving systems in an uninterrupted manner. The cable management covers the cables and the facilities connecting the shore-side connecting points and the shipbound power receiving facilities. The cable-connected facilities must meet the requirements of the quick connection and storage and be stored on ships, onboard ships, on the shore, or on barges when not used. The ship-side electrical system is an additional power receiving unit based on the original shipbound power distribution system, including cable winches, transformers, and relevant management systems. The methodology we used is comprised of total cost calculations and total benefit calculations, and total costs has been calculated as the cost of infrastructure for cold ironing system, operational cost for ships at port, and yearly maintenance cost, as well as environmental costs from cold ironing system and ships at port, and the price of electricity received from the city grid. The main approach for benefits is establishing the calculations from environmental cost of the unused auxiliary engines and the price of electricity sold to the ships when using cold ironing systems by port. This is the analysis steps which showcases the process of calculating costs and benefits. For the total monetary costs, they are established as the financial annuities of port operations for each ship, the cost of initial investment for cold ironing, annuities of maintenance costs, and cost of receiving electricity from the city grid for each ship. Price of electricity from the source has been established as the industrial usage on medium voltage according to the most recent pricing from the Republic of Turkey Energy Market Regulatory Authority, or in Turkish EPDK. Environmental cost calculation has been established as the product of the amount of electricity required per ship and the product of emission factors and external costs of each ship, each pollutant at port, and emission source from the ship, emission source from the boiler of the ship. This is because while with cold ironing, only the vessel boilers remain switched on, at port. The reasoning for boilers to remain operational at port is that it is much more beneficial in consideration of fuel consumption and emission for smaller berth periods than shutting it off and then switching it on when the ship leaves the berth. For environmental benefit assessment, SOx, NOx, and CO2 pollutants reduction achieved by utilization of cold ironing system has been calculated with the external cost and emission factors for each pollutant. When the cold ironing system is utilized, ships do not need the power source from the auxiliary engines to run the operations or regular life on board at berth. And the total environment cost from ship's auxiliary engines of a pollutant released from the ship using low sulfur has been included. The total financial benefit is calculated with the product of the amount of energy given to the ship and the price of that energy. The cost-benefit analysis case study for this container port has been carried out to investigate the feasibility of the cold ironing system in container ports with an environmental focus for the years between 2020 and 2030. The data for ships and time spent at port has been gathered from a container port in Turkey, and 1,048 viable data out of 1,060 container ships has been extracted from the collective data, roughly representing the number of ships the port in this case study holds over a year. The cost of infrastructure, maintenance, and operational cost has been calculated in consideration of the previous recent studies that have been carried out on cold ironing feasibility. And the port facility chosen for this case study provide berthing for up to 4 ships depending on the ship length. For the maximum evaluation number of berths has been set as 4. And since it is aimed to provide cold ironing to all ships during their cargo operations and considering the cold ironing system to be applied on 4 berths at the same time, also maximizes the total monetary and environmental costs. In these figures, it shows the results of the data, or the summary of the data we have collected. The categorization of the ships has been conducted as ship's length, container capacity in TEU, and the time spent at berth. These are the average times on the cursor. These are the average time spent at berth per ship category, and they are categorized as the container capacity, and the yearly percentage of the case ports hosted ships. In the results, when the total benefits and the total costs are compared in 10 years, the benefit to cost ratio shows, although the initial investment cost and the annuities are relatively expensive for cold ironing system, the effect of the ships not using their auxiliary engines provides an exceptional benefit from an environmental perspective. In the year's end, there's a 47.2% benefit, and in 10 years, there's a 46.1% benefit, including environmental and financial benefits. So this observation is emphasized with the benefit to cost ratio of environmental costs and environmental benefits, resulting in 38.2% for 10 years and further proved beneficial with the total benefit to cost ratio for the current year's end with the 47.5%. Financially, cold ironing systems are not observably beneficial for the initial year, but calculated to be beneficial in a beneficial tendency for the 10 years period, reaching nearly 39.7% in profits. This is made with the assumption of the selling price, while for profiting purposes, port management may increase the price in consideration of the costs depending on the region. By multiplying the emission factors and the annual fuel consumption, the effect of cold ironing operation on the total CO2 emissions is presented in the figure on the right. Accordingly, cold ironing provides a 62.8% decrease in annual carbon dioxide emission at the port, since ships are not using their auxiliary engines, and this results in correlation with the environmental benefit to cost ratio, showcasing that cold ironing systems are a powerful application for the greening of ports and green port projects. Now, for completing this study's presentation, I have a couple of remarks, 5 to be exact. And the main purpose of the sustainability in ports is to increase the financial performance of ports, reduce carbon dioxide emissions, provide greener service, protect the environment, and consume less, and act economically for the future of the world. Green terminals are responsible for being in coordination with their local areas, promoting high efficiency, increasing collective trade, improving the overall framework, and connecting with the community. The cold ironing system has been proven to be a promising technique that provides many environmental and social benefits by reducing air pollution from ships moored in ports. For a local air quality perspective, a ship using cold ironing is preferably to one using auxiliary engines to meet the requirement of power on board operations at berths. From the financial perspective, although the profitability for the initial year is calculated to be not beneficial, in 10 years in the long run, the investment cost and annual costs, as well as the price of receiving electricity from the source, has seen to be beneficial with the estimated energy selling price to the ship. This benefit can be increased more with the greener approaches other than cold ironing, such as ports generating their own electricity and cutting up some of the energy received from the city grid or the local grid, and giving their own energy, their own produced energy to the ships, and increasing their profitability. The cold ironing systems are projected to be a great option for both enabling environmentally beneficial industry and financial profitability in the long investment period in Turkey. Thank you for listening.
Thank you, Mr. Köseoğlu.
Thank you.
I'm sure it will be doctor soon. And
hopefully.
For the very important, very good topic and the study presentation. Stage is open for the questions and comments. While the other participants are thinking, that cold ironing particularly was important, I believe, during the still COVID time, especially a cruise vessel couldn't travel. They had to keep at berth, so they had to just keep running the system. And then that was a bit question whether it's good, like they are always in the city. So the emission increased, but maybe cold ironing helped them to a bit reduce the emission, where these ports are close to the living areas. During the COVID, many ships couldn't do their business as usual, so they had to keep at berth and in the port. Maybe would you include something like? Maybe you can comment or on this during COVID. Is there such a measurement has been done? How much the emission change during this pandemic period? Because the ship couldn't really travel. I don't know, maybe containers was exceptional. But...
I mean, I believe in the first couple of months of the COVID, because of the shutting down of the factories, the container industry has been hit, or generally the maritime industry has been hit hard. But later on, as the delivery or shippings has increased and the factories opened with the precautions, since the from door-to-door delivery systems, or such as big companies such as Amazon, or there are a couple of other initiatives have increased the effectiveness or the need for the maritime industry, specifically for container shipping, and that may have caused an increase in emission, but the port times of container ships are limited, as we all know, and because of the fast operations. But the data, such data is not in my reach, but I haven't been able to obtain such data. As we may all know, obtaining data in maritime industry is very hard, and we do what we can with what we have. But on a comment on the cruise shipping, the cold ironing system has been utilized in Europe or in the United States or other developed countries as a means of supplying energy to the cruise ships while they're at board, because they consume tremendous amount of energy on their time at board or during their travels, and which also resulting in high emissions in cruise vacation areas. Kuşadası is an example for that. There's a cruise shipping port, I believe, and they have tried cold ironing systems, but in Turkey, honestly, cold ironing systems are not really regulated correctly, because I believe there is no cold ironing application that continuing cold ironing application. There are some feasibility works for Marport that Istanbul Technical University, I believe, have carried out in 2020 for Marport, but they also found out that the cold ironing is beneficial. But when I met them and when I met other ports HSAQ departments, they informed me that there's a problem with taxing of the energy, because since the ports are basically are the areas that basically they are international areas, giving energy from ports from Turkey to a ship, let's say with a Marshall flag, can be considered as selling electricity to internationally selling electricity, which also resulting in import-export taxes, high import-export taxes. So there has to be a regulation on that manner if the feasibility of such application will be carried out, or the regulation, the cold ironing systems should be included in the green ports criteria of Turkey. The standards in the TSA, TSE, and should include such regulation on that manner, because the green port certificates are given by the TSE and the Minister of Infrastructure, or Minister of Environment, sorry.
Okay, very good. Any comments from this question, other participants? Supposed to check YouTube as well.
Yes, I can say maybe 2 sentences. Thank you very much for your interesting and well-prepared presentation, I say. Cold ironing is an alternative to decrease emissions for marine vehicles. It is interesting. There are studies with the economic perspective of cold ironing in different ports. We realistically define the emission, how the source of the cold ironing. If in Tuzla, if I give cold ironing services to the ships, the electricity we obtained consists some emission of the source, the electricity production plant, of course. So cold iron will remain always is a topic, and there will be a competition on that. You should produce electricity with less emission, so cold ironing, it will force also the price, I think. Also cold ironing monetary unit per kilowatt hour, I think. I superficially have information on that. Very interesting study. Thank you.
Thank you.
Yeah, that's Istanbul port is going to open. Maybe you can establish a measurement device there. How much, and I'm sure Istanbul governor will be interested in how much it will impact the that region, the emission, because the new port supposed to attract the big cruise ships, and you have no emissions with cold iron. Maybe they would like to hear this one. And practical work. And another thing is there's a study 2015 by Balini and Rozzo about the 60% cruise ship vessel reduce the emission. Apart from container, it's cold iron is, I think, it's very important, like the port cities like Istanbul, Tekirdağ, kind of Kuşadası. I think that's very important. Thank you very much.
Thank you for your insight.
I think